it needs a generated body, of course. Now, attribute info is going to need a gameplay tag to identify which attribute this info is for. So we're info, and here we go. Welcome back. Now we had a list of steps, and we've accomplished step 1, where we've created our secondary attribute gameplay tags, and we handle them in C++ now, as we're creating them natively with our singleton or gameplay tags. Now we need an attribute info data asset, basically an asset that we can use to store info in the form of a struct, which we're going to create called f-ora attribute info struct. So we're really going to knock out 2 and 3 in this video. So let's do it. So from within the editor, I'm going to make another C++ class, and this time it's going to be a data asset. So I'm going to go to C++ classes, Aura public, and this is related to the ability system. I'm going to open ability system here and make a new C++ class, and this is going to be a data asset. So I'm going to go to all classes and search for data asset and choose data asset and click subfolder called data attribute and create the class asset inside of the data free open ability system info, which is a U data asset. I'm going to like them because they give us the opportunity to store asset information in a nice blueprint settable class. So I'm going to go ahead and right click on attribute info.h, close other tabs, and use Control-K-O or Alt-O in Writer to open up the companion file. So I have the h and .cpp files. And in attribute info, we're going to want to store some structs. And we haven't created the struct yet, but we want to create a struct to store all the information associated with a given attribute. So once an attribute changes, then we can broadcast this struct object up to the widget blueprints who will receive it and update themselves with that information. So I'd like to make a struct, and I'd like it to be for attribute info. So I'm going to declare a new struct called f-ora attribute info. And we'd like to be able to use this in Blueprint. It needs to be Blueprint type, so we're going to give it a use struct macro with Blueprint type. And that means it needs a generated body, of course. Now, attribute info is going to need a gameplay tag to identify which attribute this info is for. So we're going to use gameplay tags to identify attributes. This will be an f-gameplay tag then, and we're going to call it attribute tag. And if we're using f-gameplay tag, well, we now need to include the header file for gameplay tag container.h. So there we have it. And we also need a U property, and we want to set this from the blueprint of our data asset. So we're going to make this edit, at least edit defaults only, and blueprint read only. And we can initialize this with an empty f-gameplay tag, like so. So that's how we'll identify each of these struct objects, is by gameplay tag. Now, the information that we need to pass up to the widget side is going to require some text for the attribute name, so we can set that attribute name in the attribute menu. And whenever we have text that's user-facing in a widget, we use ftext. So if you're ever wondering when to use ftext, that's for the widgets. That's when we set the text for a widget to show to the user. So we're going to have an ftext called attribute name. This will be an empty ftext. And these will all get the same U property macro. So we'll go ahead and copy that over. And we'll also have another ftext for the description. So I'm going to go ahead and copy this, and this will be attribute description. And aside from that, we just need an attribute value. So we're going to have a float for attribute value. This will be broadcast up to the blueprint. We'll initialize it to 0 and give it a U property, but I don't want to be able to edit this from within our data asset. So we're not going to expose it to the data asset. We're just going to expose the blueprint to read from, but it's public in the struct. So here in C++, we can set its value before we broadcast it up to the blueprint side, but we're not going to expose it to the data asset just because that's not where the attribute value is set. So if we did set it from the data asset, we'd just be overwriting it later when we check that attribute's true value. So now we have our struct. And if we need to later, we can always add more fields to the struct. But for now, this is great. And we want our data asset to contain something filled with structs. To me, an array comes to mind. So let's make a public section here, and we'll create a T array of type f-ora attribute info. And this is going to be called attribute information. This will contain our attribute info structs. Now we need to fill this in, and we're going to fill it in the blueprint. So we're going to give it a U property and make this edit defaults only, blueprint read only. So this is our list of actor info. So we'll set that from the blueprint. But I'd like a function here that will take a gameplay tag and return the correct info, the correct attribute info from this array based on the gameplay tag. So I want a function that returns an f-ora attribute info called find attribute info for tag. and this will take a const f gameplay tag reference called attribute tag, and we'll pass in a Boolean called blog not found. And I'll make it false by default. And if we pass true into this, then if we try to find an attribute info struct from this array that does not exist there, then we'll use a log to log an error. And this can be a const function. So let's make this a lookup function. Now we have an array, and this function is taking in a gameplay tag for the attribute. So how are we going to find the ability info struct in our array that has this attribute tag? Well, we can use a for loop. We can say for, let's do a const f or attribute info reference called info. So for each of these in attribute information, then we can check the tag. We can say if info.attribute tag double equals our attribute tag passed in. So we can use double equals. There's also the matches tag exact function. So if you don't want to use double equals, you could use info.attribute tag dot matches tag exact, passing in attribute tag. This will check for an exact match. So if you wanted to, you could do this instead. Either way is fine. If it does match, then we return this info that we're on. So we just simply return info. And if we loop through the entire array and we never return, then we make it down here, which means we never found an attribute info in the array. And we can log an error if blog not found is true. So if we pass in true, that means we want to see an error when we don't get a successful attribute info, when we don't find one from the array. So we can use uelog. Now we haven't defined our own custom log category, but for now we can use log temp error. And for the message, we can say can't find info, capital info, for attribute tag. And we can even say what the tag is, %s there, on attribute info. And we can even have the name of this class here. We'll put a period there. And we need two strings. First will be our attribute tag. We can use toString. And next will be the name of this class. And we can use with an asterisk get name safe, passing in this. And this is going to print an error message if we can't find anything in the array. But we still need to return something. So in that case, we'll return an empty f-ora attribute info. So now we have a function we can call, and it's a public function, that we can simply pass in a tag to and receive the attribute info. This was one of those challenges that we had mapped out that we needed to be able to find. Once we have a gameplay tag that is associated with an attribute, we can get this attribute info data asset and get the aura attribute info structure out of this data asset. So now that we have the data asset, we can fill it in with information. So I can go ahead and compile and launch the editor, and we can make a blueprint based on this data asset. So back in the editor, let's make our data asset by going to blueprints and ability system. And we already have a data folder where we've placed data tables. Now we're going to have our data assets be placed here as well. So we right click, we go to miscellaneous and look for data asset. Here is one. And we search for our class attribute info. And here it is. Let's grab that, select it. We'll prefix it with DA for data asset. And we'll call this DA attribute info. And we'll open this up, and here's our array called attribute information. And if we click plus, we now have an element with index 0, and we have 3 fields we can set. Attribute tag, attribute name, that's an f text, and attribute description, another F tags information, and we'll open DA. And here's our array. Called attribute information. And if we click plus, we now have an element with index 0, and we have 3 fields we can set. Attribute tag, attribute name, that's an f text, and attribute description, another f text. Now, there's an attribute value in this struct, but we did not make it exposed so that we can set it in details panels. Remember, we made it only exposed to the event graph with blueprint read only. The others are exposed to the details panel, and we can set them. So we can go ahead and add elements to this array for each of our attributes. And I'll start with the primaries. So first, I'm going to expand the dropdown, go to attributes, primary, and choose intelligence. And we can go ahead and fill in the attribute name, intelligence. We can fill in the attribute description, which I have already in my C++ project. If you'll recall, all I have to open is my Aura gameplay tags, actually not the header file, but the CPP file. And here, I've already added comments for each of these tags. And the intelligence one has increases magical damage. I'm not sure why I chose intelligence first, but it's there, and I can go ahead and paste that comment there. So all we have to do is put all the attributes here. And that's a repetitive process, and I'm going to go ahead and time-lapse it and fill this out. Okay, so I've added all the primary and all the secondary attributes here. Now there's kind of a lot of them, so if you really wanted to, you could have multiple arrays here, but I'm just going to have one single array where I can set this information. And all it has is the tag, the attribute name, and the attribute description, which we'd like to use once we start broadcasting delegates that our widgets can bind to and receive this information. So this is looking great, and we've already conquered the first 3 steps here in our next steps for the attribute menu. In fact, act number 4 was to fill in the data asset, so we've already done that. Next, we need to create our widget controller for the attribute menu, so we can start driving data to the attribute menu to show the values of our attributes. So that is our next step. And we'll do that next. Excellent. Welcome back. It's time for your next challenge. Now you're going to make a new widget controller for the attribute menu. Call this attribute menu widget controller and base this off of our base class Aura widget controller. So make sure that you do that so you can inherit a couple of functions that are important. You're going to override those. You can go ahead and leave them empty for now, but override them so you have them in your class. This is all stuff that you're familiar with. You should be able to do this without any problem. So pause the video and make your widget controller now. All right, welcome back. Now I just opened my editor. There's my attribute info data asset, but I'm done with it for now. I know it's all filled out. It's all looking good. I'm going to close it. I'm going to close project settings, and we're going to make our widget controller class. So I'm going to go into C++ classes, Aura, public. This will go into UI, and I have a widget controller folder. I'm going to put it here, and this will be based on Aura widget controller. So I'm going to right click on that, make a class derived based on Aura. Aura widget controller. So I'm going to right click on that, make a class derived from it. That saves me some searching there, and this will be called my attribute menu widget controller. So attribute menu widget controller. Let's create that class. I'm going to go ahead and let the editor close, and I'm going to get that open. So I don't need these files. I'm going to close all tabs and open my widget controller. There's my CPP. Here's my header file. And we have it. Now I want a public section. And we're going to override a couple of important functions, as we've mentioned. We want to override bind callbacks to dependencies. So we're going to say virtual void bind. Go ahead and let writer fill that out for me. And virtual void broadcast initial values. So we have those two very important functions. And that's looking great. We can go ahead and generate the definitions for these both. And we don't need the call to super definitions for these And that's looking great. We can go ahead and generate the definitions for these both. If we open Aura these cases, we're going to go ahead and not do that. We'll just have to remember if we put something in the parent class that we want called, then we'll come back and call super when we add that. If we do, we'll just have to remember if we put something in the parent class that we want called, then we'll come back and call super when we add that. If we do. So now that we have bind callbacks to dependencies and broadcast initial values, and we have our widget controller class, this is great because this will be used by our attribute menu, which means our attribute menu needs to have its widget controller set, or at least find a way to set the widget controller itself. And we need a place that this widget controller should be constructed. Now, if you'll recall, our other widget controller, overlay widget controller, is constructed in aurahud.cpp. It's constructed with the getOverlayWidgetController function, which requires widget controller params, right? Now, widget controllers have those 4 key variables that can be packaged up into widget controller params. So our AuraHUD is probably a good place to construct and store all of these, as the AuraHUD class itself has an overlay widget controller variable. Now, it's private. We have to go through the getter to get it. And if the getter sees that this hasn't been constructed yet, it will construct one for the first time and return it, right? So this is the pattern that I'd like to follow for our new attribute menu widget controller. We're going to set all of that up. I'd like to do that next. And I'd also like a way for us to easily get the widget controller without having to go through a bunch of classes in order to find the widget controller. Because if we'd like a widget to set its own widget controller, I don't want it to have to find the HUD class and ask the HUD class for a widget controller. I'd like just some really easy to use blueprint function that we can use to access the widget controller. And this is a perfect use case for creating a blueprint function library. If we create a blueprint function library, we can create some blueprint callable static functions, perhaps, and we can use those functions to access things in an easy manner in Blueprint. So that's one of the things I'd like to do next. We'll have a nice blueprint function library that we can use to access the widget controllers, of which our project should only have one for the overlay widget controller and only one for the attribute menu widget controller as well. So we'll do those things next, and I'll see you soon. Welcome back. For the overlay widget controller and only one for the attribute menu widget controller as well. So now, I'd like a way to access our widget controllers for our project, at least those that should only exist as a single instance. There shouldn't be copies constructed all over the place. That would be our overlay and our attribute menu widget controllers. If we go into attribute menu and open up our WBP attribute menu, then I'd like to be able to go into the attribute menu, into the event graph, right click and type something like get attribute menu widget controller, something like that. And I'd love if it popped up right here, a nice little function with this name that returns the attribute menu widget controller. And then as soon as this attribute menu gets constructed, say in event construct, for example, I'd like it to set its own widget controller. I like this because I don't really want to have to do that from the overlay class. You see, the overlay, WBP overlay, could set the widget controller as soon as we click the attribute menu button, because we're constructing the attribute menu widget here. We could take it and say set widget controller, but I really would like if the attribute menu could handle that itself as soon as we create it. Now, we can't really do that with some of the widgets in the overlay, such as our health and mana globes, because timing is important here, and the widget controller for the overlay is set at a specific time, and the health and mana globes share that widget controller. So we do want to time this correctly. We want to make sure that our overlay widget controller is set before our globes widget controllers are set. So in this case, the overlay can set those widget controllers, but for the attribute menu, as soon as we click that button, we're constructing a new attribute menu. I'd like the attribute menu to handle setting its own widget controller, especially because it's a different widget controller than the overlay has. The overlay uses the overlay widget controller class. Attribute menu is now going to use its own attribute menu widget controller class. So for that reason, I'd like to create a blueprint function library. What's a blueprint function library? Well, if you right click in the event graph and type get ability system component, for example, and select that and hover over it, you see that the target is ability system blueprint library. That's a blueprint function library. It's a bunch of static functions, usually static, that are declared in a class, such as the ability system blueprint library class, and usually exposed to blueprint in the form of these blueprint nodes. This is a blueprint pure function, and we've already looked into the insides of this function and seen how it accesses ability system components when it's given an actor. We're going to make our own ability system blueprint library for our project. So I'd like to do that now. Let's go into C++ classes Aura public, and we need to decide where we'd like this function library. And really, it could go anywhere. If we're going to call this something with ability system in the name, perhaps we should stick it in the ability system folder, and we could just put it right here next to the ability system component and attribute set classes. So I'd like to do that. Let's make a new class. I'm going to right click new C++ class, choose all classes, and now we need to ask ourselves, what is the C++ class for a blueprint function library? Well, typing in blueprint function library is a great start, and there it is, blueprint function library. Let's create this, and I'd like to call this class Aura ability system library. So we have our own ability ability this, and there it is. This blueprints class have our own ability system library called Aura ability system library. We could call it Aura ability system blueprint library like that. But then again, no, we can't because the class creation wizard here is telling us we can't go above 32 characters. So Aura ability system library it is. Let's create the class and close the editor. Go ahead and save everything there. And we should get our new ability system blueprint library class. Why don't we open it up? First, I'm going to close everything else, close all tabs, and open up the CPP and open up the .h. And here we have it. So now we have a blueprint function library. Pretty cool. Now I'm going to add a public section. And the first thing I'm going to do is add a getter for the widget controller, the overlay widget controller that already exists, just so we can test out our new function library and see if it works in Blueprint. Now, with Blueprint function libraries, we usually make these static functions. In fact, we always make them static functions because we don't plan on creating an instance of this class. We just plan on calling it static functions. So we make a static function, and this function is going to return the UOverlay widget controller type. Now it's asking if we want to include or forward declare. We're going to forward declare because we just need a function declaration here. And we're going to call this getOverlay widget controller. Now here's the thing, this is a static function, and if we're going to trace our way all the way up to the HUD somehow, we need to trace up to the HUD using an object that exists. But a static function cannot access any objects that exist in the world. Why? Because the class itself that the static function belongs to may not exist in the world. The static function can be called directly. And this is the reason why many function libraries in the engine require a world context object. It needs a reference that it can use to trace its way up somehow, some way to something in the world that we want to affect. So our getOverlay widget controller class needs a world context object, some kind of object that we can use to have context for the world that we're in. This is going to be a const UObject pointer called world context object. So we have a static function declaration. Great. But I'd like this to be exposed to Blueprint. It'll be a U function. And this can be Blueprint pure. It doesn't need an execution pin or or anything like that. It's just going to perform some kind of operation and return a result. And we'll give it a category as well. And the category can be, I'll have Aura Ability System Library and a subcategory of Widget Controller. So that looks nice and neat. So we'll generate the definition. And here we need to somehow, some way, get the widget controller and return it. to the color. So how do we do that? Well, we need the player controller. So here's the thing. We're planning on calling this from a widget, most likely. I don't really see any other reason to call this function. Widgets need widget controllers. So if we're calling this from within a widget, we're calling it from the perspective of a local player. A widget will only exist for the local player. And we'll want the player controller associated with that game instance, with that session. In other words, we can get the first player controller. So what I'm going to do is call the gamePlayStatics function, uGamePlayStatics, get player controller. And of course, we need to include the gamePlayStatics header file if we want to call this function. That's in Kismet. So Kismet / gamePlayStatics.h. And what does this function require? Well, it requires a world context object. We just happen to have one because we made this a requirement to be passed in when we call the function. And get player controller needs an index, and we're going to use 0. So now that we have a player controller, we're going to store it, a player controller. We'll call it PC for player controller. And we'll just check to make sure that this is not a null pointer. And from the player controller, we can always access the HUD. So we'll do this if check variable declaration trick again. We'll say if, and in the if statement, we'll say a aura HUD. We're going to cast to aura HUD. So we're going to say aura HUD equals cast to a aura HUD because we want that class. And we're going to use PC get HUD because the player controller can always get the HUD. And we need to alt enter a writer trick or just include aura HUD. And now we have access to the aura HUD, but we're only inside this if we succeed, and we should. Now we have the HUD. We want to call get overlay widget controller on the HUD, right? We want to say aura HUD get overlay widget controller. But this getter requires an f widget controller param. We need this struct, and we need to fill it in with the 4 key variables, which means we need to make sure we have those. So before we get ahead of ourselves and try to call that function, we need those 4 variables. We already have the player controller, but we also need the player state. We can get that from the player controller. We can say a aura player state, a aura player state. We'll call this PS. We can get that from PC by calling get player state. Now the reason I made it an aura player state is because get player state can take an input template parameter, so we can just specify aura player state right there. And now we have the player state. Now we also need the ability system component and the attribute set. Well, we cast to aura player state. Aura player state has functions for both of those. So we can say PS get attribute set, get ability system component. How convenient. So let's make a U ability system component pointer called ASC. We'll initialize it with PS get ability system component. And we'll make a U attribute set as well. That's a pointer. We'll call it AS. And we'll use PS get attribute set. So now we have